Let's do an exercise with a relatively simple set of data, namely PepperPrice, which is a price for black and white pepper long ago. And the plan is that we load the data, we do a visual with the base graphics in R, and then we do more or less the same visualization in ggplot. It will be another video. First things first, we load the library, then we load data from this library. It is a bit unusual that you don't see a symbol of a data table, and it's not a data table. You can see some part of the data with the head. You can also ask what for class of this data, and it says it's a time series. That's why you cannot see the data table. You still can call for a summary and see highs and lows for black and white pepper, and you can do a plot of this data directly. But of course, the options are limited, and you cannot do all the graphics and all the analysis with this with this class of the variable. Therefore, you need a conversion into a data frame, so you do it. The data frame can be seen, but the time is lost. So in addition, you run this line extracting time. It's in a column number 3. So now it is a time. A bit weird format, but acceptable. The class, the type is double, so it is a number, but the class is still time series, although you can integrate it into your data frame as a separate column if you want. For our purposes, it's not exactly necessary. So let's first do a histogram. It's pretty standard when you deal with unknown data. And here are the prices for both black and white peppers. There is some model maximum here, but it's not a nice bell shape. It is skewed to the left with the tail to the right. You can do these histograms in separate, and they show basically the same stuff. There is another option of looking at the overall distribution, is a density plot. So you can do density plot for all the data, or you can do a density plot for instance, first column black. I think it is. Yes, black is first, white is second. So if you want to project two densities on one plot, then it is a bit tricky. So you direct density plot results for white into D2 variable first, although your first plot is gone. Then you restore the first plot for black, and now with the option lines, and generated data are in D2 X and Y. You have it both. In a lemma library, which is mostly for gene expression, you can also pick the function plot densities. It does more or less the same. Let's move to a box plot. So the differences are obvious. You can also project strip chart, which again reiterates that this long tail upwards. And as you remember, boxplot interprets data as more or less normal, and so all the tail, the most of the tail is in the outliers area. You can also make your box plot more colorful, adding 2 colors, not necessarily one, and it will be in colors. The same you can do with the strip chart, only I inverted colors to make it cool. And if you want a violin plot, which is basically improvement of a box plot to some degree, that you see density and the mean and the highs and lows all together, then you have to load library viaplot, because violin plot is absent in the base graphics. There is no violin plot there. You do it. Here we are. So here inside you have a mini box plot with the same quartile, so easy to navigate, and the median value. And another version of it is a hist plot. Then we go to descriptive stats. If we will take a t-test, and we will try t-test, it relies on mean and standard deviation. Therefore, it would be not bad to visualize where are the means, mean values and standard deviations. So we first plot the violin, then we define mean for black and for white, then we draw them as uplines. It's a special function which draws mostly horizontal vertical lines, so H for horizontal. So mean value is over here for black, and red line is for white over here, mean value. Then standard deviations, also visualize it with the vertical lines. This is what will be taken for t-test. So this mean and this standard deviation, and this mean, this standard deviation, which is of course not ideal. Again, you totally ignore details of this data, so they will be not considered at all. Useless for this plot is a dot chart as usual. It's pretty ugly and not really saving. You see the trends that it's fluctuating in black and white, but it's far too complicated way to look at the data, not helpful. Calling bar plot, and biologists like to call bar plot, is a wrong idea, because you can use it for mean values of black and white prices, but it's not informative. So you don't see any data distribution, and this is major problem with the bar plot in general when it is used for mean values. Then you can use a bar plot in time. For instance, first 50 points in time for black and white pepper, but again you miss the scale, because now it is bars instead of the scale, and it's inferior to the time plot anyway. Analytical part. As I promised, we can do a t-test, but remember what we take for a t-test. This is what we take for a t-test. And it says that p-value is 10 minus 13, and we also can ask what's the fold difference. You calculate out of t-test, and the fold difference white divided by black prices on average is 1.4, but be aware that it is a ratio between a blue and red line, and these means are nowhere at the place of median or model maximum. you can do the t.test, or you switch to wilcoxon, which is simply analyzing ranks, not the value but the ranks. And then again it says yes, highly significant. So we can ask also, do they correlate these prices in time? And you might guess they must. And indeed they do. And you can also do a correlation test, Pearson correlation. It says again highly significant correlation, but very high rho, close to 1. I personally prefer LM because with LM I know the slope value and can do predictions, and it also has a test for significance and how much variance it explains. It is nearly 100%, so very high degree of correlation. And extra value that you can plot predicted data as lines, and then the illustrative part is complete. And you can do similar analysis with your own data.